Today I'm going to go over volumes by cylindrical shells, and the cylindrical shell is shown right here from our example, and it shows right here in general sitting on the x-axis as the circumference times the height with the thickness dx or delta x. 2 pi r will be the circumference times the height, usually it's f of x, and the thickness delta x becomes dx once we take the limit. Let's get started. Use the method of cylindrical shells to find the volume generated by the region bounded by the given curves about the y-axis. Now I have y equals 4x minus x to the second and y equals x about the y-axis. To graph the first one, y equals 4x minus x to the second, we could rewrite it in standard form or descending order, which is y equals negative x to the second plus 4x. Now notice that a is negative, which means the graph is a parabola that opens down. To find the x-intercepts, we could factor it, and by factoring or setting it equal to 0 and factor, we could take minus x out, and we'll have x from the first term and the negative 4 from the second term because we took a minus out. That shows two zeros or two solutions, x equals 0, and the second one comes from here, adding 4 to both sides, that would be x equals 4. So the graph opens down and intersects at x equals 0 and x equals 4. Now of course the vertex will be right in the middle at x equals 2. And when you plug in 2 right here, I have 4 times 2, which is 8, minus 2 to the second, that's minus 4. 8 minus 4 is 4. So the vertex will be at 2, 4. For the second function or curve, y equals x in green, to find the region between both, that's a straight line going through 0, 0, 1, 1, and so on. To find the region between them, we need to find the intersection. So we set them equal to each other, y1 and y2. That says 4x minus x to the second equals x. Then we could subtract x from both sides to have everything on the left. And that will give me 0 on the right, 4x minus x, which is 3x. So I do have 3x minus x to the second equals 0. Let's factor x out, 1x out. I have x out times 3 minus x by taking one of them outside as a common factor. Setting both equal to 0, x equals 0, 3 minus x equals 0. That will give me x equals 0 and will give me x equals 3. That's the intersection points. Now we should have a clear picture about the graph, and the graph should look like this. The parabola intersects the x-axis at 0 and 4, and the midpoint at x equals 2 will give me the vertex. Plug in 2, you get 4. Opens down. The second one in green, y equals x, goes through 0, 0, 3, 3, and that 3, 3 came up from the intersection points. At x equals 0 and at x equals 3, they both have the same value, which is 3. This will be a cross section to use Riemann sum with delta x. So we are going with delta x. Slices against perpendicular to the x-axis. Now we're going to go about the y-axis. So we need this region to go about the y-axis. So that's going to reflect on the left with a reflection image. So about the y-axis. Now we have the whole thing. I do have the image on the left, and I do have a cross-sectional area or cross-sectional volume that is a cylindrical shell. Now the difference between this graph and the basic graph where it says 2 pi r times f of x as a height, this f of x is not sitting on the x-axis. So we just need to pay attention to the height clearly and radius, because we need to use it in the formula. Let's move on to a new slide and push everything to the left. This is the region. Going about the y-axis, I see the reflection, and it's going to be a volume. Of course, it's going to go all the way around. I don't want to add more lines right here and here. It's going to be distracting my cylindrical shell sample that we are looking at. This is the radius of the cylindrical shell, and this would be the height in yellow highlighted of the cylindrical shell. The volume in general is from A to B, 2 pi r, that's the circumference, times the height times the thickness. In this case, the radius is x. From this point to this point is called x value. And f of x, which is the height, that will be the yellow part from this point to this point. That's the yellow part. Next, dx will be the thickness, of course. That's this dx. 2 pi times x instead of r. And the height is everything from this point, which is on the red graph, down to the x-axis. From this point all the way down, that is 4x minus x to the second. Minus from the green graph all the way down, which is minus x. That's why I have it 4x minus x to the second minus x. This whole thing is 4x minus x to the second, and this right here is x. The difference is in yellow, and that is the height of the cylindrical shell. That's the main part of the problem. Seeing the graph and the intersection points, the cylindrical shell sample, and the height and the radius. Once you put it in, after that becomes regular steps. So let's finish the problem. Now, inside it's 4x minus x to the second minus x, so it's 4x minus x, that's 3x minus x to the second. Taking this x in with the distributive property, I will have 3x to the second minus x cubed, or minus x cubed plus 3x to the second. Taking 2 pi outside of the integration, it's a constant. Integrating with respect to x, that's going to be minus x to the 4 over 4, or negative 1/4 x to the 4, plus 3x to the third over 3, the 3 cancels. Of course, we're going to plug in 3 and not worry about 0, because every single term has an x in it, and there is no need to waste the time and plug in 0. 2 pi times negative 1/4 times 3 to the 4th, that's 81 over 4, plus 3 to the 3rd, which is 27. One more time, we're not subtracting 0, there is no need. Simplifying the two fractions right here, or the two numbers inside, I get 27 over 4. 2 and 4 simplifies to 2 at the bottom side, and that is 27 over 2 pi. Notice right here I did not take the time to show you the calculations, because that's not really a major step in our video. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.